Hey friends, welcome to One Little Coder. Automatic speech recognition ASR, as we say, is not easy. It's not very easy for anyone to do it like how you do NLP. So for NLP, you have a bunch of libraries like Hugging Face. You just import it, and then in a few lines of code, you actually can have a state-of-the-art model in place. But that's not the case with ASR, and that is about to change because Hugging Face has been recently working on the Wav2Vec2 model from Facebook AI. It came as part of their Transformers library, but recently Patrick Von Platten released a nice tutorial of how you can fine-tune XLSR Wav2Vec2 model for languages with less resources. So you can actually take that existing XLSR Wav2Vec2 model and then fine-tune it at a checkpoint for a language which has less audio resources, and that model still works fine. So we will see very briefly about what the brief details, and then we'll just jump straight ahead into see how to do that. I'm not using any resource that I created. All credit goes to the Hugging Face team and Patrick Von Platten. So Hugging Face also currently has a sprint kind of like the way they did it for dataset. So this video is to encourage you to create a model for your own language, so that the same way NLP has been democratized for all languages other than just English, you can also democratize ASR models for other languages, not just English. So that's the motivation of this video. I hope this is helpful for you. So please stay till the last. So what is it? First of all, Wav2Vec2 is a pre-trained model for automatic speech recognition. So like we have seen in a previous video how Wav2Vec2 we used from Hugging Face library to transcribe English audio to English text. But what you can also do with that is there is a very similar representation model. It says XLSR Wav2Vec2. So the XLSR in that stands for cross-lingual speech representation, as you can see. So which means you can use it for multiple other languages as well. So what this tutorial actually shows you is how you can take this XLSR Wav2Vec2 model and then fine-tune it for a language which has a low resource, like you don't have enough dataset ASR for that. So you can fine-tune the existing the pre-trained XLSR model from Wav2Vec2, and you can fine-tune it for a resource like some language. Like in this case they're showing it with Turkish, but I'm going to show you how you can do it for Hindi, which is an Indian language. A lot of people are usually interested in Hindi speech recognition. So you can actually see how am I doing it. I'm not going to completely download the model. It actually takes a lot of time, but we'll see how to do it. So this fine-tuning is based on a method called connectionist temporal classification. You can read more about it, and then there are links for it. So the other important information is the metric that has been used here to measure the accuracy of the model is word error rate. Again, that has been linked here. You can start looking into it. So with these details, like we just saw, so we are going to take the XLSR Wav2Vec2 model, then we are going to fine tune it on a language which has less resource, and then at a checkpoint we are going to take that model and start using it for automated speech recognition ASR. So let's go ahead and then start look at the Colab notebook. So the Colab notebook, you can open it from here, and that's what it opens here. So but I would advise you to keep a copy. So go to file. So I want to do step by step, so that's why I'm showing this. Go to file. Okay, Colab wants to know if I'm a human being. So let me show that I'm a human being. It's still loading. Okay, so just click file. Make sure that you're logged into your Google account, because when you save it, save a copy in your drive, when you do that, it's going to create a copy. So basically you have to log into your Google account, and that's where you're storing it. Once you do that, change the title based on what you want. Here in this case I want to do it for Hindi, so I'm writing it Hindi in the title. It doesn't make a lot of difference, but yeah. So then connect your notebook to the computation machine. If it's not connected, so in my case it's not connected. So it says too many active session. Okay, let me close this session, which I don't need actually. Okay, let's say cancel and connect it, whether it does it. It should, ideally. Okay, have to manage this session. Terminate it, close it, connect it back. Again, if these things are very easy for you to understand, you can just straight away go ahead and start using this notebook. Just trying to show how it is. So it's connected to the computation, the engine. So once you start, first install the latest packages. So transformers, we are installing it, the latest one for 4.4.0. Dataset is where we are going to take the dataset from Common Voice Mozilla. We'll just quickly see it. Torch Audio and Librosa is for audio resampling and manipulation. And finally, Gver is what we are going to use it for, word error rate, the metric. So install all these things. While this is getting installed, I would like to show you the Common Voice Mozilla page. It's an open source initiative. If you want to donate audio files of the desired language, you can actually do it. So they've got a lot of languages in here. So if you want to do it for any language other than Hindi, like I'm showing, so you can do it for like multiple Indian languages as well. So you can do it for like Tamil. You can do it for like, you can see all the languages that are available here. Like Tamil is there, probably Punjabi is there. Then you would see Odisha is there. Odia is there. I think IJKLM. We see Malayalam, so Malayalam is not there. Okay, Hindi is there, and Persian is there. So I'm just looking at a few Indian languages, so you can see the other languages as well, like Assamese is there. So you can see the languages that are available now. So you just have to use the right code for that language. For Hindi it is HI. So once you know that the installation has been successful, so the next thing is we need a tokenizer and feature extractor. So we need a feature extractor that can actually take a feature from the audio files and give it in the format that transformers deal with, like as a vector. So yeah, you can actually read the blog post. It's very self-explanatory, good English. I mean, when I say good English, it means you don't need really good deep learning knowledge to understand that. But yeah, so what we are doing is, now at this point we are taking data set from Common Voice, and we are going to download dataset for Hindi. So this is the step where the Hindi dataset is getting downloaded, and all of these would take some time. For example, recently I did for another language. It actually took me quite some time, not in these processes, but when I went to the actual training, fine-tuning of the model, it took time. So let's see how much time it takes. So we are removing the columns that are not required for us. Again, like I said, you can read the description for you to know why we are doing such a thing. So you saw that at one place we changed TR to HI. So that's one change we did. Yep. So going ahead, you can actually see like some random data from this. It would show some yeah, you can actually see random Hindi elements like kahan gaye ho, tum aaj busy ho kya. So you can actually see the Hindi text, and this text is because like it is associated, associated audio is also there, and that's what this entire fine tuning is, right? So the original pre-trained model was created on a large amount of speech corpus which was not labeled, and then now to take it for a particular language, we're fine-tuning it with a labeled small labeled dataset. Few characters that we are removing, maybe it may not be entirely relevant for the language that we are dealing with, but like we're just going with the flow. So removing special character, after removing special character, you can actually see if anything else has changed. Random elements. So I mean, like, I don't think in Hindi you have that problem. So you can actually see like yahan mera ka kutta hai. So yeah, Meri kutta hai. So I'm sorry, my Hindi is bad, but so the next thing is extracting the characters. Let's move fast. You probably do not need any guidance for this thing. So there are a few things that I want. So these are the individual letters that are available. So there are some English letters. I'm still not sure why it is there. Again, my intention is not to show you the best. So probably these are the cases you have to take care of. Like for example, you're trying to remove some characters, special characters. Probably you could include like English letters as well, because we're of course training Hindi model and we don't want English characters. So once that is done, let's we can see the vocabulary dictionary. Okay, that's done, and you can save the files that you need. It's just vocabulary dictionary. So this is going to act as our tokenizer. So at this point you can see that this is going to act as our tokenizer. So we have saved vocab.json the right mode, like which means like in your current working directory is saved, and from that we are actually loading this, and then it has been initialized. So did I run this? Okay, I ran this 2 times. So once that is done, you can see the parameters. You can play with the parameters. So right now we are initiating the Wav2Vec feature extractor, and the processor is again like we have an audio file, so you need processor. So probably the place where I wanted to spend some time explaining you is these models are actually so heavy. So at every checkpoint it's going to generate probably 4 GB file. So which means unless you're training it on your like own machine with a lot of storage, it's going to be slightly difficult if you're using Colab. So you need to make sure that your Google Drive has enough space. So that's one thing that I would probably tell you. So when you are in this cell, uncomment it, because you wouldn't have mounted your Google Drive at this point. So run it. Google would ask you to put the authentication. So open it in your new tab, and then the usual sign in thing is going to be there. Yeah, probably this is the most important part that I wanted to focus in this video for somebody who has never mounted their drive. So like I said, the objective of this video for me is to enable anyone and everyone, because that's what exactly Hugging Face is doing. So this beautiful blog post is to enable you to create a model for your language. So I'm going to say inside my drive, I'm going to call it a Hindi demo. Hindi, like we just call it Hindi. Yeah, save the pre-trained model here, and I can go to my drive. And then you would probably see it here, like the drive content, my drive, cool Wav2. Yeah, you can actually see that here. So right now these are the files, but once you start actually training, you would start getting it. So let's load a sample train file. You can see तुम्हारे पास 3 महीनों बच्चे हैं. So like I think it says in Hindi that you're left with 3 months. So the other important thing is you need to resample it. So that's where we are using Torch Audio to resample the format and sampling rate. Okay, we are actually using LibRosa to downsample. Okay, so that's done. Let's map it. And again, this might take quite some time because we are dealing with huge audio files. That's done. Run this. Once that is done, the resampling process, you can see we are I think downsampling it to 16 kilohertz. So as the text says, Common Voice audios are usually sampled at 48 kilohertz. We are downsampling it to 16. So once this process finishes, we are almost in. Okay, are you still using? I don't understand what Google thinks. Like, I don't. I don't know why I sound like a robot. Like, not sound, but my activities. I don't think. I mean, it's not like I've disappeared or something. So the other thing probably that you should keep in mind is when you're going to do fine tuning, you're like this is going to take like hours and hours, like probably 8 hours, 9 hours, 7 hours, depending upon the size of data that you've got, and then the number of yeah, like sometimes when you have a smaller checkpoint, then you need to also make sure you're clearing up your Google Drive space. So you need to find some way to keep your machine not sleep. So on Mac, you can caffeinate it. So like you can go to your terminal and then you can caffeinate it, and when you caffeinate it, then your Mac wouldn't sleep. So you can either do it or go to the settings and you can change. On Windows machine, you can, I think, switch off the power saver option. It's still loading. I don't know why it still has to think. Colab is for interactive use. Please confirm that you are present. I don't want to click cancel and then them closing my Colab session. So just closing the tabs that are probably not required. The blog post. Okay, let me just cancel it for the moment. Okay, so this is the place where you can actually see the audio file itself. Okay, let me just play the audio file.
मुझे याकी तौरी खाना बहुत पसंद है मुझे याकी तौरी खाना बहुत पसंद है
So you could have probably heard the Hindi audio. So like for any language that you do, so this is a place where you can actually check the correct audio file, so that you can also like slightly be sure about uh, yeah. So there is a text file. You can actually see, like you can do all these texts. So now we are preparing the data set for training, and let's run it. So at this point we should have a like common voice train and common voice test file. Once that is done, we can start the training process. So this is, we don't have to do anything here, just set up the trainer, then set up the evaluation metric. So define the function to create the evaluation metric, print the evaluation metric, and this is where the main, like probably the magic thing begins. So you can actually see that we are loading the main pre-trained model, which is the large XLSR model 53 from Facebook, and directly it's hosted on Hugging Face Hub, loading it. So these hyperparameter these parameters, hyperparameters, are actually something that Patrick came up with after doing a few iterations for the Turkish language. So if you're going to do it for Turkish, probably you can just go with this. But if you're doing it for other languages, he suggests you play with it and then select the one that you like, and what is the dropout that you're going to set, or the other values that you would like to set here. But just because we are doing demonstration, I'm going with whatever it is exactly there. But playing with these hyperparameters might help you improve your model, but also you need a lot of patience. Run it. Yep, model is defined. Okay, it's getting downloaded. it's probably 1.2 gig. It's getting downloaded, and you can see like every time you store something on your local drive, so your Google Drive, I think you have got 15 GB of Google Drive, so that Google Drive is actually getting full. So when I was doing this, like before this video, what I had to do is after every iteration, like you have a drive 15 GB, and I think one checkpoint would probably store around like 4 GB ish, 4 GB ish. So you need to make sure like when you hit probably like 12 GB, you clear out all checkpoints. So that is why it is important for you to pay attention to the model, the metrics that you get. Now at this point, the training argument should define. This is the place where you want to store the output. So I'm when training, I think we have created it called Hindi. So make sure you give the same name so that the drives are not getting confused. So this, whatever we are training, it would get saved there. So the other thing that probably you want to make sure is after how many steps you want to save. So let me add a comment. This this would mean every 400 steps model gets saved, which also means Google Drive gets full. So if you want to save at every 400 steps, so imagine like 4 GB for every 400 step. So by the time you hit 1200 or 1600, your drive is going to be probably full. So you might have to clear out the old model. So it is again up to you whether you want to save steps every 400 or whether you want to save every 600, every 1200, every 800. But this is again one particular thing that you need to keep in mind. So you can keep 400 as your step, and then you can probably check your evaluation metric, and then you can see like probably it is your evaluation metric, like your training loss is going down or WER is going down, word error rate. If that's happening, then you can like clear out the old checkpoint stored on your Google Drive. But if that is not the case, probably then you might have to note down what is a checkpoint where you had the most efficient score, and then clear out everything else and then keep it. So again, play around with these things based on the time that you have, everything that you have. Like I am just for the sake of demo, I am going with a very high learning rate. When you increase your learning rate, your model is going to get trained faster, but there is a very high chance that you don't converge, you start overfitting. So yeah, you know all these things, right? If you don't want to do anything, don't change anything at all, just keep it as it is. Only thing that you need to keep in mind is probably add this is just for demo. So only thing that you need to keep in mind is your Google Drive is going to get full very soon. So you need to make sure that it doesn't get full, because if it gets full, Google is going to automatically put your checkpoints in trash, and then you would probably miss out the most efficient model. Trainer is defined. So the other thing is there are two things that might sleep. One thing is your machine can sleep, like whether you're using a Windows machine or Mac machine, your machine can sleep. So the second thing is your Google Colab session can sleep. So there are two things, right? So, and it takes a lot of time, like it probably takes out like 6-7 hours sometimes, depending upon the amount of data that you have got. So what you have to make sure is you have to like first make sure that your computer doesn't sleep, like your Windows or a Mac machine. The second thing is your the session that you have got, it doesn't sleep. So the trick here is, if you want it not to sleep, copy this function. Okay, copy this function, right click. Okay, sorry. So you can go developer tools, go to console, paste this code, run it. Okay, so that means that ideally it is not supposed to sleep. Yeah, I'm not a JavaScript expert, but Yeah, just make sure that your session doesn't sleep. Just run it on your console, and then it's time to move forward. So you can see what happened with Turkish case. Let me explain it before we start for Hindi. So at every step we were saving at 400. Your training loss is coming down. You can see your word error rate is coming down. If you actually see at a point that let's say like it hit 0.50, then it starts going like 0.51, 0.52, 0.53, then probably that is where your convergence is. Again, this could be like silly for anyone who understands machine learning, but like again, my purpose of this video is for anyone who is passionate about a language to develop an ASR model for their language. So yeah, so probably for you, if your Google Drive is getting full, make sure you don't delete the checkpoint that has the lowest WER. So that's something that you need to make sure. And also you need to make sure that your model is not, like it missed converging because the learning rate is high, started going up. So let me just run it. I'm not going to run it completely. Probably it will take 6 hours for nothing. I'm just going to show you how it happens. So after that is done, once that is done, your model is saved. You will start seeing checkpoints file getting saved here, and after that you can load that model from there, like in the same path where you saved. Like what is the path? So this is the path where you saved. You can load the model from the same path. Okay, active session GPU used. You can load. So this is for you to check the model finally. So you can keep the same path. Because we are saving it on Google Drive. If you are saving it on a local machine, you can take that path. So wherever you have saved this model, and wherever your final checkpoint is, right? So what it is going to do is for every checkpoint, it's going to create a folder. Checkpoint 400, checkpoint 800, checkpoint 1200. For every checkpoint, it's going to create a folder. So what we want to do is we want to take the best one, and then that path is what you want here. So make sure that is the path that you want here, and then once you give that, then you can start evaluating the model. It's not something I'm going to show because the model is not going to get trained at all, but the idea is to show you that it is how it is done. Like once you save the model, you have the model in place. Okay, probably I'm hitting the RAM. Let me just check my runtime. Change runtime. Is it GPU? Yes, GPU. Yeah. You can actually see once you run it, like you have to load Hindi audio again from that file. Once you do that, you can check for Hindi file. So every time from now onwards, when you want to use this model for any ASR for Hindi, so this is like this piece of the code is what you would want. Like you take the model, you take the processor, you take the dataset after the pre-processing that we did at the start. You take give that audio file inside the processor, and then it converts into dictionary, and then you give it a model, and you predict, and then you compare it with the test value, and you try to understand whether it has done a good job. So yeah, let me just close it. Okay, so the way it shows the session, I think that's triggered by that JavaScript, that snippet that we ran to keep the Colab session not sleeping. So I think I'll just let it run, and then I'll probably close this video. So the objective of this video is to take you through the blog post, a beautiful blog post that Patrick has put together. So once again, thanks so much, Patrick and the Hugging Face team, for writing on such a detailed blog post that anyone can like just get started with running your model or fine-tuning the XLSR-Wav2Vec2 model, which is to democratize ASR for your language. I would also encourage you to use or upload the model that if you have trained a model for your own language. I would encourage you to go to Hugging Face Model Hub and then start uploading that model. The process is quite simple. I'm not going to show you everything, but you can go to Hugging Face First, you need to create an account on Hugging Face. Once you create an account, you can go to Hugging Face/new, and then that will take you to the repository where you want the model to be created, and then you can start creating the model. So you can go there and then you can give the model name, and then you can create the metadata model card. Everything is very well laid out. I'll probably link that also in the description. So that way, your model could be useful for anyone in the world. Anyone can start using it. Though you don't have to burn a lot of computer energy to just create another model which you have already created, and then it does a good job. When you upload the model, make sure that you link this notebook so that people can see how you have created the model, and also they can actually see the validation loss, training loss, WER, all these metrics that you have got, and also mention the WER, the value, so that people know how accurate the model is. They don't come up with any huge expectation like how it's for English language, because we know it's not like our model is not as good as it's going to be for English language, but nevertheless we get a model. So please try it out. If you do it for any language, I'll be really glad to know like what language you're pulling this for. And again, I am a strong advocate of having machine learning resources, pre-trained models, or data sets, whatever it is, for languages other than English, because there are a lot of languages in the world, and everyone is focusing on only English. But if you start paying attention to your own mother tongue, your own language, that can mean a lot to the people around you or from the place where you come from. So please, make sure when you run this Hindi model, and then try to upload the good Hindi model or any other language, Indian language that you've got. And this is the same step for any language. It could be Indian language, European language, or any language. This will hold true for it. That's it. It takes us to the end of the video. Thanks so much for listening to me. I hope this video was helpful to you in creating your own model, the first model, and uploading it to Hugging Face. That step is quite simple. If you're stuck somewhere, probably you would need to just figure out the Git LFS for the large files, the GBs of files. But if you're stuck somewhere, let me know in the comment section. I'll try to help you as much as I can. Once again, thank you so much for listening to me. I hope this video was helpful to you in starting your ASR journey. See you in the next video. Stay safe.